Hey, I'm Tobias from Stelzer Technologies, where the digital becomes real and the real becomes digital. Today, I want to take you behind the scenes of how TreeShaper 2.0 works. Before I show you the new and improved TreeShaper, let me show you how the first version of TreeShaper handled geometry generation and why it creates these unnatural branch attachments. The trees from TreeShaper were a combination of connected vertices and branches that formed the basis of a tree. This branching structure was created by code. On top of that were a stack of modifiers, a skin modifier to give the trees volume, a subdivision surface modifier, and a geometry node system for the twig and leaf distribution. The vertex radius for the skin modifier and the vertex weight group are also created by code. Now, if you worked a little with Blender's skin modifier, you know that it often has problems at intersections and you need to adjust the vertex position and or the radius of the vertex to get better results. For a procedural tree add-on like TreeShaper that is supposed to make your life easier, that is obviously a catastrophe. Now, apart from the skin modifier issue, I had another grievance with how the trees came out. The texture mapping of the bark texture allowed only one global mapping of the texture. I chose an object mapping with a pox projection. For straight trunks, this works quite well, and it is seamless, but when you travel up the tree, you'll notice that the bark orientation never changes, which leads to this stripe-like bark that is just wrong. Now that you have a general picture of what was wrong with TreeShaper, let me show you an old and new features of TreeShaper 2.0. Create a new tree by pressing Ctrl A, selecting Mesh and then Grow Tree. The add-on will generate a standard tree along with the collections for root and crown growth zones and no grow zones, each represented as objects in the respective collections. When you enter Edit mode, you'll notice that the mesh now consists of actual vertices, edges and faces, all laid out in clean quad topology. Honestly, I still find it incredibly satisfying to see this topology. It took a lot of work to get it right in code. The material is applied automatically to the mesh. I'll show you the UV layout a bit later. Now, you're probably wondering how to customize your tree. Let's walk through that. With the tree selected, bring up the Properties panel by pressing N, then look for the TreeShaper tab in the sidebar. Here you'll find numerous tweakable properties, like branch density, twist or trunk width. Let's adjust the trunk width and gnarliness and then press Update Tree to regenerate the mesh. As you can see, this created a strange looking root attachment. This can sometimes happen when the tree origin empty is too close to the root zone or if the gnarliness is set too high. In this case, reducing the gnarliness and updating the tree again resolves the issue. While implementing the new meshing algorithm, I discovered the potential for a new parameter, twist angle. Let me show you what it does. The twist angle rotates the trunk and branches around their own axes, creating visually intriguing structures. Almost like something out of an enchanted forest. Let's increase it a bit. Each ring segment rotates by the angle defined in the Properties panel. Earlier I mentioned the different grow zones. Let's explore how they influence the tree. First, I'll move the root zone sphere downward and reposition the tree origin empty, which controls where growth starts. Now let's add a new cube, place it above the tree and move it into the Oak Object Attractor collection to extend the crown growth zone. I also want to show you how to restrict growth using no-grow zones, which might represent obstacles. For example, I'll create a cylinder to act like a concrete post. The algorithm respects transformations made in object mode, including scaling and rotation. Just make sure not to place no-grow objects over the tree origin, or the tree won't have space to grow. Press M to move the obstacle into the tree's no-grow collection. Then select the tree, open the Properties panel again and press Update Tree. After a short calculation, the new tree conforms to the constraints. It looks a bit odd, admittedly, but it clearly demonstrates the concept. I decided I didn't like how the trunk twisted near the base, so I lowered the twirl parameter and regenerated the tree. Much better. As mentioned earlier, the algorithm automatically creates UV seams and unwraps the mesh. To check this, go into Edit mode with the tree selected and switch to the UV tab. You'll see the bark texture applied, along with UV islands for the trunk and branches. You can scale and adjust these as needed, depending on whether you're working with a small or large tree. If your tree feels too sparse, you can tweak the leaf density and leaf scale. These parameters update live without needing to regenerate the entire tree. One last note. By default, the add-on sets all grow and no-grow zone objects to wireframe mode. Especially for no-grow objects, it's a good idea to use a low-poly proxy. If you didn't do that, here's how to bring the object back. Select the wireframe object, duplicate it and move the copy into your main collection. Then, under the Object Properties viewport display, switch it from wireframe to textured. That wraps up today's video. As mentioned, the final tree here looks a little quirky, so in the next video I'll show you how to create visually pleasing trees, like the one you see in the render. That's it for today's walkthrough of TreeShaper 2.0. I hope this gave you a clearer idea of how it works and what the capabilities of the new system are. In the next video, I'll show you step by step how to build great looking trees with the help of crown clustering. If you want to support the project or see more updates, follow me on Instagram and YouTube, or grab TreeShaper from Superhive. Thanks for watching, and let your creativity bring a little more magic and wonder into the world.